So this equation comes from your block notes in the transformations, quadratic transformations section. So I'm just going to start off by saying that when you're given an equation that is not an equation with any numbers around it, it's called a child function. So it's like real life. A child comes from a parent. The parent is one person, the child is another. So it's just you're transforming the parent function into a child function. So the parent function of this equation would be y equals x squared. And the reasoning behind that is because you do have an x in here and you do have a squared. All the other numbers are considered what we call transformations. I know that doesn't make much sense yet, but just please understand that this is the parent function, which is the original. And then we have the child function, which is the transformed function. And we need to list all the transformations. And then, so I usually say describe the properties or describe the transformations, and then I ask for a graph. So here we're going to start with the parent function's table of values. So this is something that you basically memorize. The x values are -2, -1, 0, 1, and 2. If you square the x value of -2, -2 squared is 4, -1 squared is 1, 0 squared is 0, 1 squared is 1, 2 squared is 4. Like I said, these values can just be memorized so that it's a quick thing to write. Now, we're going to transform that into the child function. So we have x values. Please notice that I write the table of values for y equals x squared with the equation on top, and I write the table for the transformed child function with the equation on top for that one as well. So they're very well labeled. You know what is what. Now, we need to figure out what's being affected. So this is what I call the x sandwich. X is in the middle and y is like the bread. It's on the outside, always. So anything that's inside the bracket will affect the x's. Anything that's outside the bracket will affect the y's. But now you need to know how. So let's start with the x's since it's in the middle. You don't have to, but that's what I like to do. This comes from the original equation. I'm just going to write it down here. Y equals ax minus h squared plus k. This is called the vertex form. And in the vertex form, we have an h and a k. So when you take out the h, notice here that I didn't write negative h. I took out positive h. And positive h is the opposite of negative h. So this may look like a negative, but when you take it out, you need to take the opposite. So the opposite of negative h is positive h. So if we take a look at our equation right here, we have a -3. So it looks like it's -3, but we need to take that out and say that it's +3. So we're going to go to all of our x's and we're going to write +3 on the right here to each and every single one of our x's. So that's done. That's it. That's for your x's. Now your y's. You have to be very careful here. The y value for -2 is actually the a value, and we'll write that down in a little bit. That value is actually being multiplied by the function. So because it's being multiplied and you know that it's on the outside, it affects the y's, and that means you're going to multiply all your y values by -2. But that's not it, because there's a +6 here that needs to be taken care of. So because that does say +6 for the y values, you also have to put +6 on every single one of your y values of the original parent function. So we move on here. We just do the math. -2 plus 1, or sorry, -2 plus 3 is +1. -3 plus, well, -1 plus 3 is 2. 0 plus 3 is 3. 1 plus 3 is 4. And you can see the pattern here that the last value will be 5 because 2 plus 3 is 5. Be careful with your multiplications. 4 times -2 is -8. -8 plus 6 is -2. Then we have 1 times -2. -2 plus 6 is 4. 0 times -2 is 0. 0 plus 6 is 6. And then because this is your vertex, and these values match, and these values match, the same applies over here. So your vertex is the third value down, Now the next value should be a 4, and the next value after that should be -2, but we're just gonna double check that. 1 times -2 plus 6 is 4, and 4 times -2 is -8 plus 6 is -2. So there's just patterns when you're dealing with parabolas because the values do go down, but then they go right back up to the same y values. So that's how you create the table of values, just like this, but there's a little bit more. You do have to list, I should have just kept that equation here, but here it is again. You do have to describe the properties. So the properties are listing what your A value is, what your H value is, and what your K value is. So the A value is a number in front of the bracket. So the number that's in front of our bracket here is -2. So A equals -2. If it's negative, I want you to take a look what that does. So here's my parent function, y equals x squared, and there's a -2 in front of my bracket. So I'm gonna do that, and I'm gonna put x squared. So as you can see, it's flipped upside down. So if you were to put a mirror right in the middle on your x-axis, that means that it would reflect. So that's why it's called a reflection in the x-axis. Okay, so when there's a negative, it's a reflection on the x-axis. This is the only reflection you see this year. It's the only reflection. So reflection on the x-axis. Now, the A value always has 2 things, but sometimes 3. This is the one that depends. If you don't have a negative value, then there is no reflection. So you wouldn't have to write it. But in this case, we're gonna have 3. So we need to tell the property if it opens up or down. In this case, we know it opens down because A is less than 0. And then we need to decide if it's a vertical stretch or a compression. So when we're looking at that, we don't look at the negative part. So the negative part has to do with the reflection only. Once that's gone, you can basically erase it and take a look at just the number. And because the number 2 is bigger than 1, then it's a vertical stretch. And the way you write this is that it's a vertical stretch by a factor of just 2. Remember that the negative is with the reflection. So you have to like split them up, okay? Now, if it were a compression, it would be a decimal. A compression is when a number is between 0 and 1. And the only types of numbers between 0 and 1 are decimals. So that's it for A. We've got our 3 things, but sometimes there's only 2, so remember that. The H value, as you remembered, looks like it's -3, but you have to remember to take the opposite, so it's actually H equals +3, which means it's a translation, which means it moves of 3 units, and because it's plus, it's going to the right. So I'll just show you what that looks like on Desmos here. I'm just gonna add a +3, whoops, in the bracket, x. There you go. As you can see, my equation is x minus 3, but my parabola is moving 3 units to the right. Okay, so be careful with that. It's always the opposite. And then finally, we have the last value of k, and k is equal to +6. It's also a translation, which means it's gonna move of 6 units, and this time it's going up. Now, I forgot to mention that because it's moving to the right, it's a horizontal translation. And the trick that I like to use for that is that the word H and horizontal starts with the letter H. That's my little trick there. And my trick for the K is that vertical, there's the sound K. So that's K, which means vertical. And if it's vertical, it means it's going up and down. If it's horizontal, it means it's going left and right. So I'm gonna add the +6 to my Desmos here, and you'll be able to see that the parabola moved up 6. The only thing that wasn't fully explained is what the stretch looks like on a graph, but I'm gonna get to that in the next couple days. So hopefully that helped. Just make sure that you review the X sandwich, what affects the X's, what affects the Y's, and then knowing where your A, where your H, and where your K is, and which properties belong to each and one of them.